Good morning, good afternoon, good evening, and welcome to OpenShift TV. This hour, we are doing the OpenShift Administrator Office Hours with myself, Chris Short, executive producer of OpenShift TV, and the one and only Andrew Sullivan. Andrew, please introduce yourself for the audience.
The internet handicapped Andrew Sullivan today.
Yes, we should put out that disclaimer now.
Yeah. So, hello, everyone. Andrew Sullivan, technical marketing manager with Red Hat Cloud Platforms. So, Chris and I are teammates, as we have been for a couple of years now. It's been a while.
Has it been 2 years? No. Has it
No.
really?
Well, I've been here for a couple of years.
You've been here for a couple of years. I've been here for
it's been at least a year
months.
Now. Yeah.
It's been over a year. Yeah.
So, well, we're happy to have you.
Oh, thank you.
So this is the administrator's office hours, which means that this is an Ask Me Anything style time period where you can, well, ask us anything. And I mean that quite literally. Well, hopefully you'll want to stay on topic around OpenShift.
Don't ask us to the answer for, success to human life or whatever. We've got 42 as the general answer for that. But otherwise, yeah, literally ask us anything Red Hat tech related. We got you covered, or we'll find you an answer eventually. Yeah.
Yeah. So whether that's, and as Chris just pointed out, whether that's one of us answering your question directly, or whether it's us doing some research and finding the right people inside of Red Hat to get those answers, that's what we're here for. So that being said, in the absence of your questions, and again, please feel free to ask us questions through any of the various chat or social media mechanisms. We'll try and stay on top of those. In the absence of that, we do have a couple of topics, a couple of things to talk about today. So first, I do want to highlight, as we kind of started out at the top of the hour or at the top of the show, I was poking fun at myself and my internet. So my internet is having some difficulties today. It actually started yesterday, but it should be fine.
Like we've done some assessments and it should be okay.
Yeah, so upload speed is phenomenal. I love having bidirectional gigabit, but download speed has been suffering. So hopefully everything will go fine. I was doing a presentation with a customer yesterday and it just completely cut out. And fortunately, Christian happened to be there and he just picked it up and rolled with it because Christian's good like that. Yeah, Christian's good like that. So it worked out well.
Believe it or not, JP Date, Andrew does not have Comcast. I have Comcast, which is why the stream went out in the middle of a stream one day because they upgraded me.
So yeah, I actually so Ting is my internet service provider, and they have actually been phenomenal for the 4+ years I've had them now.
Wow, buddy, that's a lot.
Literally I think this is the second time we've had an issue. Coincidentally, they're both within 2 months of each other.
Ooh.
But the first time it was completely not their fault. Basically, somebody got overzealous with a backhoe and cut a bunch of fibers.
I cannot tell you how many Air Force bases I have seen disappear off the internet because of that.
Yep. Or I was on a base one time and it was a tank ran over the wrong part of the road and crushed the pipe underneath. Whoops.
Yeah. No.
Anyways.
So about our old battle stories about fiber, yeah.
And this time it is still not Ting's fault, at least what they've told us. It's basically their upstream provider. So it's not just my area, it is or my ISP, it is a broad swath of this area. So,
and if you know anything about BGP and how the internet works, that shouldn't surprise you at all.
Yeah, was it T-Mobile? T-Mobile had
a full-blown outage.
Yeah,
you couldn't use their network.
Well, and it not only borked their network, it borked like some large percentage of the internet. So,
yeah.
This is why I'm not a network engineer.
I got out of that game when I realized that I could easily trample over anybody's like BGP routes and send all their traffic my way. It's like, oh, I don't like that. That was back in the V2 days. V3 is a little bit better, but not much.
Yeah, it's, again, too much pressure for me. Way too much pressure for me. All right, so I'm going to start sharing my desktop because
we've got one question, though.
I love doing that. Sure.
So Dennis Online asks, I've been trying to find info on exactly what the offline flag does or is supposed to do in CoreOS installer. And if it's anything like the offline flag in Ansible, it might not do anything.
That's a good question. Let's
see
if we can figure that out. we'll go to the handy dandy documentation here.
Yes. Offline. Nothing found.
And I think if we scroll down far enough, we will eventually come to all of the different options that are available here. Offline, forced offline installation. So my guess would be, and this is completely off the top of my head without testing or validating, that will, as the name implies, force an offline installation, meaning it will not try and connect to the external registries for the images. So if you are unfamiliar with the OpenShift installation process, essentially OpenShift, when we install OpenShift, the first thing we do is put down a Kubernetes cluster, then we install OLM, Operator Lifecycle Manager, and then we use OLM to deploy all of the operators that make up OpenShift. And throughout that process, it's having to constantly pull down container images. So that is, I think in total, there's something like 6.5 gigabytes if you were to pull them down and mirror them. But that, my guess would be, using the offline option is going to force it, is going to ensure that it does not try and connect to that outside registry. It's going to make sure that it only tries to go to your inside registry.
Yes. Okay. So there's more questions pouring in now. I'm going to let you tag this one as I go get the link to answer the other one. Today, CoreOS is not truly immutable, i.e. MCO can make changes and it will persist across restarts. So can someone with cluster admin privileges writing to just the right place on the file system? Okay. Any roadmap on making CoreOS truly immutable? So you can configure CoreOS to be truly immutable if you so desire. That means not using the machine config operator, which takes away a lot of functionality from OpenShift. But Andrew, your take on that as I get the answer to what's new in OpenShift real quick for somebody else.
Yeah, so yes, OpenShift, and I'll just detract slightly to answer that other question. Yes, it was released, 4.6 was released yesterday, and the link will be, the most succinct place will be the release notes in the documentation.
Oh, I already know what it, duh.
But there's also the what's new presentation
that
was
page.
streamed.
Yeah. We actually have a what's new page.
OpenShift.com/what's new.
Yeah, I just remembered that. I need to actually create a command
so
of that.
Yeah. Immutability. So yes, CoreOS is quote unquote immutable. So let's talk about what that actually means. So it doesn't mean that the operating system can't be modified. It just means that it is always in a known state. And in particular with RPMOS tree and the way that CoreOS works, this means that machine config operator, this means that, and now we have the, or we'll soon have the file integrity operator, right? We can verify and we know the state that that CoreOS operating system is supposed to be in. But we can go in and we can lay out files, right? You can use, and if you were to look at, do I have a cluster up and running? I don't think I have a cluster running at the moment, which is strange. Oh, I know why.
I have a cluster. Do you need a cluster? I can send you Brad's. Hang on.
No, if you were to, what I would do if I had a cluster running would be to look at the machine config operator. And if you look inside of there, and if you look at the machine configs that are defined for the pool, it lays out a bunch of files. And the difference is, or what happens is, I install CoreOS, it's on a particular RPMOS tree version, and then MCO lays out all of those files. And that is persistent, quote unquote, until the next update, at which point it will flip over to the new RPMOS tree and relay out all of that information that's needed inside of there. At least that's my understanding. I would like to verify that, and I probably should verify that through a couple of different testing methods.
I just sent you the email with the creds and everything. I can slide it to you as well.
So yeah, I'm sitting here going, why don't I have a cluster? And it's because I flipped over my lab to being vSphere today, and I don't have a.
I busted my cluster the other day, and I haven't stood it back yet. But luckily, I have one in our handy dandy portal or partner development system, right? That's RHPDS.
RHPDS, yeah. The Red Hat partner
demo
system? Or product demo
Product
system.
demo system. That's right. Duh.
Yes.
Just find your name in all the sea of Slack. There we go. Here we go.
Yeah,
Ta-da.
so I see there's also a question from Taskeen. I'm completely new to OpenShift. Hey, welcome to the party.
Yeah.
Glad you could join us. Would like to learn about managed OpenShift on IBM Cloud. Could you please give some insights?
I'm actually grabbing a link for that right now.
Oh, aren't you just on the ball today?
I'm trying to be.
So
like, I'm gonna send you to a landing page. Please use it as like kick tires, light fires kind of thing. But that's gonna help you the most, I feel like, getting started. But there's a lot of ways to do IBM or OpenShift right now.
Yeah, and so I'll take a slightly different approach, which is so any of the managed services, whether it's IBM, OpenShift on IBM Cloud, whether it's OpenShift on Azure, OpenShift on AWS, any of the managed offerings. Effectively, what you're doing is having somebody else do the operations, the administrator side of things. So you can focus on the developer side of things. So what that means is if you go to any of our resources, so learn.openshift.com, openshift.com/try, et cetera, and you look for those different learning scenarios, then that'll walk you through all of those processes, all of those features, functions, et cetera. So you can really focus on things like pipelines or service mesh or whatever that happens to be, and not have to worry about, well, today I need to, click the upgrade button and how's that going to affect things. Right. Instead, the managed service folks take care of all of that for you.
Yes. So yeah, you've got to make a decision as far as what you want to do and how you want to do it.
But yeah, I don't know the specifics of how any of the managed services actually, what that looks like underneath, what type of compute instances or storage instances or whatever that happens to be. I don't know what that looks like underneath. We could ask, actually, I would have to find out who the new product manager is, because the old product manager is now part of he just moved over to our field organization, which was Patrick. Patrick and I have known each other for a long time, since we sat next to each other.
Yeah.
Yeah, since we sat next to each other at previous employer.
Nice.
So
$ previous employer. Thank you for sending everybody over
here.
Anyways, so let's see. General onboarding, I would just head to learn.openshift.com or red.ht/streamlearn. There's also the What's New deck. That's right. Thank you, Zenny. That's out there on our speaker deck page. I'm having a problem with words today. Can you tell? How
too much coffee or not enough coffee?
Not enough coffee, and the fact I have to wake up and take pain meds is just struggling through life right now. Anyways, how did you two get into Kubernetes and OpenShift? What did your learning paths look like? I think that's kind of a wide-ranging question, and I'd like to hear your answer first.
Yeah, one slight detraction, C Group Ninja. Hopefully we sort of addressed your question. I feel like it wasn't necessarily a complete or a thorough explanation. If you could provide clarification on what you mean by making CoreOS truly immutable, like what does that look like to you?
Yeah,
maybe we can talk
I am
about
curious.
That. So how did I get into Kubernetes? So way back when I was working at a previous employer, who's a storage company, I joined that company to be specifically a VMware technical marketing engineer. So I did a number of projects, basically saw that the VMware side of things was stagnating. So they were continuing on their path, but I was on a team of 9 or 10, all VMware TMEs. And wanted to branch out. And my manager is, hey, thanks for finishing up this project. It was a best practices guide that I had rewritten and updated. So what do you want to do for the next few months, right? You can take a break from this VMware stuff. And that was when I began investigating containers. And the first time I deployed Kubernetes was back in the Kubernetes 0.7 days, 0.5 days.
Wow.
Yeah, it was like I had to compile Sky DNS, right? It wasn't even Core DNS at the time. and
Jeez.
integrates all of those. Yeah, and that's how
Wow.
I got started. And then I found there was a couple other people in the company
Hmm.
that I was friends with that had also, we had, the three of us had independently started looking into containers and just kind of went from there. And
Wow.
we started the whole containers thing over there, and it continues to this day. I got involved in OpenShift because of because I was part of the partner team at the time, and of course, Red Hat and OpenShift and all of that meant that I needed to learn about how OpenShift works. So it was very
Nice.
much a gradual thing. I have a very heavy operations background. Um, like I once played a developer on TV. I was terrible at it, so I moved over to being on the operations side. Um,
That's awesome. So my journey was a little different. I came at it from the community angle, and I saw Kubernetes kind of on the horizon way back in 2015, 16 ish. And I was like, yeah, I really need to learn this Kubernetes thing. And I sat down one day, I forget when or what or whatever. It was pre-Max, so it was 2015, probably. And
is that
I
BC, before kids? Although
yeah,
I know
before
you have an
kids.
older. I know you have
Yeah,
an
no,
older one,
well,
but
yeah, the older one wasn't with me at the time, but she wasn't with her mom in Ohio. The like the way I learned Ansible, I went into my office 4 hours later, I came out and I was like, I'm an Ansible genius, right? Like the way I learned Kubernetes, I went into my office, I stood up a cluster on Raspberry Pis, and 8 hours later, I came out and I'm like, this is going to change the world. And this was like, 2015. So I was very right. It was going to change the world and how we do things. But I already had experience with OpenShift, right? Like I used the gears and cartridges at a previous job. So I was like, well, if Red Hat is seeing Kubernetes as the way of the future, I should probably at least understand it. And so I got involved in the project, specifically within SIG, Kubernetes SIG ContribX, contributor experience. I started off in docs, did a little bit of help there, and I realized that like getting the contributor experience stuff would be better, like bringing more people on. I'm very good at bringing new people on the tech, and my skills were better suited for that. So I got involved that way, and it's kind of just been learn more, learn more, learn more ever since. And here I am working for Red Hat on the OpenShift team. So yeah, I kind of went at it very differently than Andrew did, but still got to the same kind of spot. And yeah, it's good to have those two stories, I feel like. So I came at it from the community angle, and then started working for a vendor that had a Kubernetes project in OpenShift, and uh, you know, came to Red Hat as Ansible person, and then worked on a bunch of Ansible Kubernetes type stuff, Ansible operators specifically, and then came over to the OpenShift side to come help Andrew and company,
yeah.
help folks learn OpenShift essentially.
Yeah, I will say, so to answer the second part of your question there about learning path. So for me, it's been very different than traditionally. Well,
Yeah,
I shouldn't say that. Both a little bit the same, a little bit different. So I learned by doing.
same.
I was a customer. I was a storage and virtualization architect, right? So I started as a junior administrator, became senior, became architect, worked on some very large projects in various organizations inside of the government. Some of the people that I worked with on those now work at Red Hat. Funny enough.
Eh, shocking.
So
Yeah.
when I joined my previous employer to be a tech marketing engineer, I was already intimately familiar with every aspect of that technology. Um, so being at a vendor and learning a new technology is a completely different experience.
Yes.
Right? And you've probably heard us mention before where we don't keep, like, I don't have clusters that run for a very long time on a normal day, right? I'll stand up an OpenShift cluster that'll run for a couple of weeks usually, and
Mm-hmm.
then it gets torn down and rebuilt because we're constantly testing, we're constantly checking things. How does this work? What does this look like? But I don't have an application per se that runs inside of there. So what that means is we have to be very disciplined about understanding how things work and putting them in context. But also I've taken the approach of, well, I want to have that experience, I need to do that. So I do have, for my personal stuff in my house, right, I do keep a Kubernetes cluster that I just use to What's it like to be what's
Yeah.
it like to be an administrator? What's it like to have things running inside of here?
Yeah.
And it's
Same
been
here.
a tremendous learning experience as a result of that. So, but yeah, going back to the direct, like, what's your learning path? For me, it's almost entirely hands-on. And I rely on my team very heavily. Chris, you know this. You see our internal chats all the time of constantly asking questions and, challenging my own assumptions. Eric is phenomenal at calling out, that was an assumption and you're wrong. So
he does it lovingly.
Yes. Yeah. And it's the right thing to do, right? Of, don't assume, validate.
Right.
So
trust but verify, as always. Yeah. Does this thing work the way you intend?
So Teskeen, hearing you for the first time, is there any community which I can join?
Yeah, so we have a Discord. I dropped a link to that in the chat there. So feel free. Actually, where did he come from? Teskeen came from YouTube. So let me drop it there.
I will also point out OpenShift Commons.
And yes, OpenShift Commons is a great place to get started with OKD, which is the open source version of what we do here with OpenShift. OKD actually doesn't stand for anything anymore, is my understanding. It's just a name. Like all good names, it kind of means nothing. But yes, you can join Commons and use the Commons working group to kind of get your sea legs under you with OpenShift, and then you can kind of dive into the guts of all of it as you see fit, whatever interests you the most. Maybe next episode, a live demo on how to upgrade an OpenShift cluster from 4.5 to 4.6. I can tell you it's a matter of just a couple button clicks.
Yeah, I wish I had my my cluster up, because that's on my agenda to do this week, is upgrade my own cluster.
I mean,
so
I can log into my cluster and do it if you want, but
yeah, it's in practice it should be. Did I get that email from you yet? Yeah, I did. In practice, it should be as simple as selecting the right stream, updating the channel, selecting the right stream, and then going from there. So let's rewind just a little bit here. I'm looking back at the chat. So yes, OpenShift Commons, definitely a community there, as well as our own OpenShift.tv Discord channel and community. I would also suggest, if you're a part of the CNCF Slack channel or Slack, I don't know,
Kubernetes, like join the Kubernetes Slack, join the CNCF Slack, like do the. All right, give it a second to pick up everything.
I just posted in chat.
Thank you. All right, folks, and we're back. Sorry about that. OBS up froze on the streaming rig. My bad. It apparently needed a restart more than my laptop did. All right.
It happens.
Can people upgrade on the stable channel? Yes, you can upgrade on the stable channel.
Well, yes, but not yet.
Not yet.
Yeah, so I started to discuss this, and then we lost the stream. Of if you go to and I think I'm still sharing my screen.
You are.
So if you go to the documents section, and I think it's under the installation and update section, we have, let's see here. I think it's under here. Installation process. Come on. Update service. No, it's not under there. So what I'll do is look for the blog that I wrote that I know has a link to this.
It's amazing when you write the blog, you know where to find it.
I know. Come on, scroll for me.
So JP Dade points out that the stable channel hasn't been updated yet.
Yeah, so what I'm looking for is in the documentation where it describes the different update channels. Effectively, there's fast, there's stable, and there's candidate. So when we release, so yes, to fanfare, we released OpenShift 4.6. If you have a new cluster, you can absolutely go, and today you can pull down those 4.6 bits, you can deploy a cluster, and it'll be great. For updates, though, it's a little bit different. in that it'll be available in the fast channel. So first you need to switch your OpenShift 4.5 to a fast channel, upgrade to or update to the latest version in there, and then switch to the OpenShift 4.6 fast channel, and then you can update from there. For stable, it will be probably 2 to 4 weeks before it's available in the stable channel. The reason being, we want to basically let it bake. We want to let it, it sounds bad to say that we want it to get tested by more broad use cases, but that's kind of what happens. Let the fast people do a little bit of testing and validation.
Yeah.
And that way, for the stable people, capitalize on all of that. And if they find bugs, if they find issues, essentially they will hold that release into the stable channel until 4.6.2 or 3 or whatever it takes in order to get it ready for broad updates or upgrades using the stable channel.
Yeah. I mean, and let's see. Imperam points out these 2 days ago, they've been releasing different versions. At least it has confused me. Until an hour ago, I couldn't change from candidate 4.6 to stable 4.6. Now I see it as I want it. Yeah. So like changes are happening right now in the background, folks, right? Like a release takes, we intentionally, unintentionally, however you want to phrase it, kind of slow roll the stable part, because we understand that if you're doing things in the stable channel, you intend for things not to break. So we want that to be your experience, and we're extra cautious about production workloads, as we hope most vendors are. So yeah.
Exactly. So, and I'll post this. I finally found the link that describes the different channels and the status. So I just posted that link into the chat here. Okay, so let's jump back up a bit. And I didn't forget about C Group Ninja. So similar to strings in Java, which is truly immutable, not knowing what state would be at any time, being non-modifiable. Not allowing writes even temporarily. So in the OpenShift world, that would mean any patch update, et cetera, would need to be applied on a new CoreOS instance to do the usual cord and drain dance with the old instance to the new instance. So that's kind of what happens, from my understanding, kind of with happens, the RPM OS tree and how we flip between the images. I would like to do some more investigation there and find out precisely what is or isn't modified, what gets completely, for lack of a better term, blown away, right? Whatever gets completely removed and then recreated by the machine config operator, versus anything that remains there. So that's one that I need to do a little bit more investigation there.
And I feel like yes, you can get that complete total immutable experience so long as you don't reconfigure anything with MCO. And I don't feel like that is the best use case, right? Like if you're really, really looking for an immutable OS, like 100% like locked down in that manner, there's other OSs out there, but I'm not sure if they can run OpenShift.
Well, the only one that can run OpenShift is RHEL. So,
right. So yeah, you can't really, at least in a supported fashion, you can't really lock the OS down and then say, yeah, I'm not making any machine config changes, because there's so many customers that we have that have all these different kinds of hardware that they need to then add onto their cluster to make it available, and the MCO would then, like, not having it there would make it very hard. So
yeah.
It's going to be awesome if you just, I'm trying to understand like the need for that high level of immutability. Like if you can't say what you're doing, like if you're doing some secret squirrel stuff, fine, we understand that. But if you need a 100% immutable OS in the sense that you're stating, right? Like every single change has to have like a new box. That's possible, but that's also very time consuming. So I'm trying to understand the why,
Now, part of the reason I held off on this a little bit was because we also have, and if you can see in my browser here, I have this Microsoft Word tab. This is a little thing that we made available called a hardening guide. So this is the draft CIS benchmark for OpenShift 4.5.
Very important. Draft.
Yeah, and in nice big letters here, it is a draft. This is something that we can share with customers. So if it's something that you're interested in, please feel free to reach out. And we would want to definitely.
Wants it. Yeah,
I see that.
Yeah.
So this is 217 pages of how to harden your OpenShift cluster. And it goes into, as you would expect with any of these CIS benchmarks, it goes into excruciating detail in how to check and how to look at, how to remedy, etc. All of these things.
But seriously, huge shout out to Kirsten Newcomer and the whole team that worked on this, right? Like, this is a significant amount of effort, and it is awesome that it's been done. So I'm very appreciative to everyone that's been involved.
And I will also point out, and I'm going to browse to the repo here, and I'm doing this blind. I haven't actually looked at it before. There is a pull request you can see here for the compliances code. So for the automated remedy, automated, that's not the word I'm looking for, the automated remediation tools.
There you go.
Right.
I was trying to help you.
Yeah,
I didn't know what
introduce to introduce all of this into there, so that way it's a much easier, much faster, much more convenient way of doing that. Additionally, there is the compliance operator. So the compliance operator, which is new to OpenShift 4.6, will go through and check a lot of these things as well. I don't think that CIS has been, because this is draft, we haven't released the CIS benchmark for compliance operator yet, but that is on the roadmap that's going to be happening there. So effectively, using the compliance operator, you set the benchmark that you want to use, the standard that you want to use, you tell it to scan, you look at the reports, and then depending on what you want to do, you can either remedy manually or rectify manually or in an automated fashion. So one of the many ways, one of the other things that we can do to help with the security aspect inside of an OpenShift cluster there. Yeah, and let me switch windows here.
JP8, I'll email you after the show. Sorry.
Yep.
If you don't mind. It's hard to write an email and stream at the same time.
Yeah.
No offense, buddy.
Or read email for that matter.
Yeah, right. Yeah. Have you looked at the RHEL 8 CI? Yes, I have, and it's very, very big. And there's Ansible Lockdown as a thing to help you with stinging and CISing your RHEL 8 boxes. You pulling up the cluster? Yeah, cool, awesome.
Yep.
So you're going to show us what, the MCO stuff, or?
No, I was going to do an upgrade.
Oh, that's right. Yes, there is an upgrade available on this one. It's already told me as much. Did you forget the password?
Well, I thought I copied it successfully.
Copy pasta. You think you can? No, it's OpenTLC.
Oh.
That'll do it.
Thank you.
Or OpenTLC user? I forget.
Manager.
RTFM.
There we go. You know, literally read what's in front of me here.
Yeah.
All right. So this is a 457 cluster. Let's look at what we've got here. So this one, Chris, I assume you provisioned from our HPDS, which means that it's an automated deployment happening in the background. That is, you can see here, running on top of AWS. So our HPDS, if you're not familiar with it, or if you've never heard of that before, it's the Red Hat product demo system. So it's a thing we make available to employees and partners, where you can go in, you can request access to resources, for example, an OpenShift cluster, and then be able to do things like demos or even learning, right? A lot of times we use these when we do workshops of, let's deploy a number of clusters and then hand over a workshop guide and let whoever happens to be in attendance run through and learn all of that stuff. So if I go to my cluster settings here, so I can change this to the candidate. Actually, I want to change it to the fast.
There you go.
And give that just a second to let it do its thing in the background. And what we should see is I can go all the way to 4.5.16. So if I switch this back over to stable, I think 14.
14.
No,
is the last one?
15 is the most
Okay.
recent in the stable. They must have just changed that.
Mm-hmm.
So you see with the fast, I have access to more. Exactly. So let's go ahead and hit update on that. So essentially, the way that all of this works is there are specific releases that you can upgrade from and to. So what does that look like? And I'm trying to remember. Do you remember the Cincinnati webpage?
No, I don't.
Yeah, I don't either. If I go to
Is that a Rob
GitHub,
thing? Hang on, I might have saved it.
So if I go to github.com/OpenShift and I look for Cincinnati,
nope.
So you'll see that there's a couple of different repos that show up here. So Cincinnati is the service in the background that maps all of these things together. So if we look at the Cincinnati graph data, there is going to be, if I remember correctly, somewhere inside of here, there's a image that shows, and here's all of our YAMLs. So stable 4.6, if you look in here, there is no previous versions that are eligible to update to stable 4.6. We do have a tool. It's in the documents there that'll create a giant graph or a giant image that links all these things together. I just find it to be relatively difficult to understand. So for fast 4.6, you can see that it will allow me to upgrade from 4.5.16 to 4.6.1. So what that means is that I need to be subscribed, or I need to be pointing at the fast channel here. And then I have access to this 4.5.16. Once my cluster is at 0.16, it will offer me the ability to go to 4.6.1. So that's what we're doing here. I went from, or it's in the process of going from 4.5.7 to 0.16, and then from there I can make the jump. So over time, I would expect that this list will begin to grow. So it may be that they do some additional testing, validation, QE does their thing, and maybe we add 4.5.15 or something like that. Maybe when 4.5.17 comes out, or 18 or 19, right, those will continue to be added here, as well as going to other versions of 4.6, others Z streams in 4.6. So you'll see this grow over time. Eventually it'll move over to the stable. So then you'll be able to look in the stable and be able to see what all of that looks like, or you'll be able to update if you're subscribed to the stable channel, rather, not just the fast channel.
Right. And I can drop those links in there, or if you could just drop the link in chat to that.
Yep.
Thank you. JP Date asked how much storage is support sitting on. I have no idea. To be honest with you, it's probably in the petabytes. I mean, I can only guess. I don't even know who I would ping to be like, hey, how much actual customer data do we store, and what's the life cycle and all that other stuff? I'm sure I could get that for you, but I'm sure it's also documented somewhere.
It's got to be like cloud-based. It's got to be
I'm sure
store
it's
or something.
S3 object store stuff. Yeah. It's like JP Data uploads a ton of stuff to it, so I'm sure other customers are in the same boat. So yeah, it's not something like, it's not like we have a basement full of EMC or NetApp clusters in the tower or something, right? Like, it's definitely block stored someplace.
And what's interesting, Red Hat, of course, has an IT organization. They use that for supporting internal services. So, for example, our home directories and stuff like that. If you have, for those of us that expose the tilde home web thing, that's actually hosted on a NetApp.
Yeah, it's pretty cool. Awesome. Let's see.
So one of the things that I wanted to point out here, so one of our product managers created this website, and I'll open this up in here for these update channels, where he basically makes it's an easier way to consume that YAML information that I was just showing. So let me post this into the chat here. This is an unofficial way of getting unofficial information. There are official ways of getting that same information.
Yes.
This is just the one that I always remember off the top of my head.
And thank you to Rob for putting it together.
Yes. So you can see if I click on stable 4.6, my source here is 4.6.1. If I click on fast 4.6.1, I can use 4.5. 4.5.16. If I look at, for example, stable 4.5, because that's when I'll have actual information. So you can see I can update to any of the 4.5 branches from these 4.4 branches.
Right.
So that's how you can kind of interpret this information of, I need to be on at least 4.10 is the lowest one I see here to be able to update to 4.5.1 through 4.5.15. That's the way that we interpret this information. So useful information, valuable information, particularly here in the very early days of a new release of what do I need to be on to be able to update to the latest. And as you see, the only option is fast 4.6, or excuse me, the fast channel for releases and updating to 4.5.16. So I know we've got, about 15 minutes left, 17 minutes left. So the other thing that I wanted to talk about, and I apologize, I've not been keeping an eye on chat very well.
I haven't either, and apparently something's broken over on YouTube, so I'm gonna go sit over there for a little bit.
Okay. Yeah, I see Dutch Hawk.
Oh gosh, YouTube. I don't want to change the profile picture. I want to go to the homepage, YouTube. Knock it off.
So there is a delay on the stable channel. Yes, Jan, that is correct. Thought it was 2 weeks. So it could be it could be as short as 2 weeks. I think it was 4.4. It ended up being like 6 weeks or something like that. It was a pretty long time with 4. I think it was 4.4 to do the updates for stable. I know that engineering took that very, very seriously, and they've made a lot of internal changes to make sure that long of a delay doesn't happen again. So take some solace in that. Looks like the OCP release channels link has not reached the YouTube channel. Yep, that is correct. I can post that in real quick here.
Actually, if you want to just hand it to me, or just drop it in Twitch, and I'll make sure it gets everywhere.
Oh, it's in Twitch.
Okay. Which link? Sorry.
It's the GitHub Cincinnati, or that one. You. Yeah, either or.
Okay, I'll drop them both.
So the other thing that I wanted to talk about today, and something that's very, very, very easy to miss because it hasn't been put into the right part of the documentation yet, and that is OpenShift 4.6 has a new way of doing static IP configuration with VMware. It's the reason why my lab has been flipped over to VMware today, so that we can dig into that. So the first thing we want to do here, I'm looking at the OpenShift 4.6 documentation. Let me make this a little bit bigger here, just to make it easier to read. So you can see I'm on the 4.6 docs. I'm going to go to the release notes section. As I said, that's because this is an error. It should be in the primary documentation. I think there's no less than 3 BZs that are open about it. So it'll hopefully get fixed in relatively soon. So if I do a search here for OVA, you see I come to this static IP configuration for vSphere using the OVA. And I'll post a link directly to this in the Twitch chat if you want to check on that in YouTube, Chris.
Yep.
So what we're documenting here, what we're basically saying is that as of OpenShift 4.6, CoreOS, when deployed from the OVA, will look at a specific property, VM property, and pull in the IP config information. So previously, if you wanted to do a static IP with OpenShift on vSphere, so essentially UPI, you would have to boot and install using the ISO installation method. The OVA only worked with DHCP. So now we can deploy using the OVA, and then we can add in this information, which if you see here, it's the exact same information we would append onto the kernel line. So now we can add it in as that VM property. Particularly useful if you're doing automated deployments of this type of stuff. You can see here they showed using govc. If you've created automation that uses Terraform or Ansible or whatever you want to use, it's as simple as setting this particular option. Excuse me. So let's take a look at what that looks like. So I have previously downloaded the OVA. As I said, my download bandwidth is suspect right now. So let's go and deploy an OVF template. I'm going to choose a file, and I want the, where is it? CoreOS VMware OVA here. So we'll go ahead and do next. Sure, we'll call it CoreOS. I'm not actually going to deploy a cluster here. I'm just going to deploy a single node and then configure that static IP, and we should see it come up and use that static IP when it's deployed. I've only got one host option here, so not much of a choice.
Yeah, apparently we lost a live chat when the OBS rig dropped. It's working everywhere but YouTube. Fun.
Yes. All right, so it did its validation here. We can see we're on the correct version of CoreOS. I'm going to go to this data store, which is an iSCSI data store. Yes, that's the network I want to connect it to. So I'm not going to provide ignition config data. So yes, normally when you're deploying a node, if I were deploying a cluster, I would absolutely provide ignition config data here, right? I would set this to the encoding to base 64, and I would have a big long base 64 string of that ignition config. All of that's in the documentation. I'm just skipping over that in order to show, and apologies if you heard me just bang the microphone. All of that, I just want to show this static IP configuration process here. So that's why I'm skipping over actually deploying and configuring a cluster at the moment. So we'll hit the finish there and we'll let it do its thing. What we should see here is it's down in our tasks. Hopefully this will go through. I haven't actually tested this yet in my lab, so
TBD.
You know, what's the worst that happens?
You know, you break something on a live stream and you fix it. You got 11 minutes though.
Yeah. It's plenty of time. Plenty of time.
Plenty of time.
JP Dade messing with DHCP on a Windows server. Yeah, DHCP is kind of a pain. I do like the Active Directory interface for DNS though. I find it relatively easy, especially if you're using like PowerShell to do that.
Yeah.
It's not the worst thing in the world. I'll put it that way.
This reminds me, something broke DHCP wise on my network overnight, and I got to figure that out.
Yeah, you were saying before we started that the assisted installer wasn't working for you.
Yeah, I mean, I think that's more of an error in the way I'm trying to configure the clusters, or maybe I'm reusing names wrong or something. But like, yeah, it was not working well, and it could be because DNS or DHCP, but it doesn't.
I like to think it's because you're a problem child, Chris.
Yes, and I mean, I feel like that goes without saying. I think the polite way Eric phrased it once is that I'm a power user, and then I'm trying to use like consumer equipment to do like power user stuff, and it's just not going to work often.
Yeah, that's the way all of us are, I think. You know,
yeah,
we're always pushing the boundaries of what our home labs are capable of, which are often, I don't know about you, I don't get time to go back and properly maintain my home lab, so it ends up being a jumbled pile.
Well, I think what a lot of folks don't realize is that like I'm the IT team for my entire family. So I try to keep things consistent and simple, right? So like I can administer everyone's network in my entire family from right here. And that's great, but you lose a lot of the power features that you would get with something like a Ubiquity network or something like that. But it is what it is. The Google networking stuff works great until it doesn't. I'll just leave it at that. But it used to be that hosts could self-define their own DHCP DNS host name, and now that functionality is gone, and I don't know why, or if there's some release notes that will tell me, because, well, Google.
GP did. I'm glad I don't have to pay your power bill. Two C7000.
Two C7000s? Oh my god! Oh, that is absurd. Like, do you expense your power bill, JP Dade? Like, how do you do that? Good Lord.
So
yeah, like my wife complained when I put the one server in, and I was like, fine, I'll set it to power save. I don't really need that. He says he runs the R&D
oh
lab. Oh,
yeah,
that's not your house, is it? Do you run the R&D lab in your house? Because that'd be crazy. I guess that's a good secondary location for an R&D lab, maybe.
I don't know, my boss, and by my boss I mean my wife,
Hmm.
would not allow me to have that much noise in the house. So,
Right,
which
like
I'm comfortable with that. I don't want that much noise in the house either.
no, I don't. I don't want blade chassis in my house. No, thank you. No, nothing that can hold other things. Right, like give me the 2U server, fine, but yeah, I don't want. Mm-mm. That's a lot of noise I don't need.
After sitting through this 5-minute long process just to deploy an OVA, I'm thinking I need to update from my everything's running on 1 gigabit
Ooh.
at the moment. So maybe I should update to 10 gigabit, and it seems to be getting to that time.
Well, yeah, you realize that very quickly. If you have gigabit network everywhere, any one device can saturate your 120 meg uplink. So with a gigabit uplink, though, you probably have a little more leeway. But this seems like internal and is kicking your ass.
Yeah, it is. It's all internal.
Yeah.
So it's and it's funny because it's going from my workstation to the ESXi server to another server that's hosting the storage for it. So it takes it a minute. It's a little slow. There we go. All right, so now we have our OVA. Or excuse me, we have our virtual machine inside of here. So if we follow the documentation, what I need to do is set this particular value or this particular virtual machine configuration to this string. And I'm literally going to copy this string. The 100 network is not one that exists in my house, which means that if it comes up successfully, I should be able to, it should show this IP address, and we know that it is getting that from here. So I'm going to copy this first. And then we come over here and we go to our virtual machine and we edit settings. Go to VM options and oops, I want the advanced down here. Edit configuration. And then I want to set a configuration parameter. So all I'm doing here is copying and pasting that string into this advanced configuration parameter. So I copied this string, the value where it's supposed to be, and then I'm going to copy the correct value and put it into over here where that needs to be. So we hit OK. If I look at my configuration now, and I scroll down, I see how we have this guestinfo.afterburn.init.rd.network-kargs and the IP string that we provided. So this is our expected behavior. And now I can hit cancel out of here a couple of times, and we'll turn this guy on. And again, I haven't actually tested this, so we'll see what happens.
4 minutes. Let's see.
So what I'm expecting to happen here is it will power on. It will go through an installation / setup process. It will probably reboot. And at that point, we should have our static IP that we just configured inside of there. So that IP address, well, that's not the right IP address. So that's, we'll have to see what's going on there.
Did your DHCP server see it?
Yeah, that is the DHCP address.
Yeah. Okay. I was wondering.
So we might have to, this is what where'd we go here? So I might need to reboot this node or something like that. Like I said, I haven't done this before. This is a learning opportunity for both me and you. Missing a double quote. That's possible. Or maybe it just wants me to, actually install a cluster. That's possible too. Because it would be looking for an ignition config to then pull its config, and maybe that's when it actually looks to do that configuration. Not entirely sure. So we'll have to wait and see. I wish this had worked the way that I wanted it to, or the way that I thought it would. But we'll look at that next week. I'll validate and figure out what I did wrong, and then we'll review this next week and
Cool.
get it actually up and working. Since we've only got 3 minutes now.
Yeah, we did answer a ton of questions, so I feel like today is a success regardless.
Yeah. So with only 3 minutes remaining, and my apologies for this this little demo failing here. So with 3 minutes remaining, I do want to say thank you to our audience. Really do appreciate you tuning in, with you staying with us. Appreciate the questions very, very much. If you would like to ask any questions that you didn't get a chance to today, or if you don't feel comfortable sharing them in the public chat and having us discuss them, please feel free to reach out. You can reach out on social media. I think to use a phrase of the kids these days, my DMs are open. Or what is it? Slide into the DMs. That's what it is. Something like that. I don't know. I'm too old for that. So you're welcome to reach out to me at Practical Andrew, all one word, on Twitter. You can also reach out to me via email, firstname.lastname @redhat.com. Happy to help, happy to answer those questions however we can. And if you have anything that you are interested in, if there's any subjects that you'd like us to cover on the show, I would be very, very welcome for that as well. Very open to that as well. So I think, again, next week we'll talk about static IPs with vSphere using VM properties. And maybe we'll talk about modifying or configuring /var for a different disk device if we can.
Yeah, that'd be great. Awesome. So thank you all for tuning in, and we'll see y'all 2 weeks, next week, 1 week. The show's 1 week. No,
should be next week.
Yeah, next week. That's right.
Every week, unless we have something that overrides, right?
Yeah. Sorry. The 4th. We will see you then. So happy Kubernetesing and OpenShifting until then. See you soon, folks.
Well, hello everybody, and welcome to another OpenShift Commons briefings. We're really pleased that you've joined us today, and I want to welcome the folks from Crunchy Data today. They're going to regale us with some wonderful cloud-native GIS applications using Crunchy Data on OpenShift, and we have with us today Steve Pusty, Paul Ramsey, and Adam Tim. Steve is one of my favorite people, longtime Red Hatter and fellow evangelist back in the day. So we're really thrilled to have him back here. And we've always very much loved our wonderful partners, Crunchy Data. So I think this is going to be a lot of fun. Some really great demos are in the offing. So Steve, why don't you introduce your team, take it away, and we'll have live Q&A at the end. So thanks again for joining us, everyone.
Thanks, Diane. It's really great to be able to hang out with you again, too. I've missed it. So I'm Steve Pusty. I'm the lead of developer relations at Crunchy. Paul Ramsey is I think it's executive engineer, senior engineer, something really high up in for the purposes of this talk, the important part about Paul is he is one of the founders of PostGIS. He's the lead committer, and he and Martin Davis are the two that built the Crunchy Data's Crunchy Spatial platform, which we'll be demoing today. Adam Tim, he is a wonder guy who goes between sales and consulting and grant writing and PMing and doing all sorts of stuff. He's a former NGA. I don't know if he was an analyst or not, but he was at NGA, so he cares very deeply about spatial stuff. But also being at NGA, he also was on the beginnings of cloud native stuff that the government agency was doing. So today, we're going to talk to you about some cool stuff that we've done from soup to nuts with Crunchy Data, Postgres, some cloud spatial stuff that Paul will introduce in a little bit, and we'll be running it all on OpenShift. So let's go ahead and get started. Oh, I got to click on the actual window. All right, so there's us. Oh, sorry. Paul's the one in the middle. Adam's the one who looks like he might be an NGA agent anyway, on the far right. And that's me on the far left. Actually, it's no hair framing the hair guy is what we're actually aiming for with that effect. What we're going to do, we're going to talk about some cool stuff with Kube, PostgreSQL, and spatial microservices. And of course, since we're on the Commons one, our version of Kube is going to be OpenShift. And then we're going to use these pieces to build some cool stuff in real time. So we're going to spin up you'll see, but it's almost exactly real time. Loading data is slow, so we're not going to show you loading data. Other than that, everything's going to be real time. Who's Crunchy Data? Just for a quick overview, the leading provider of trusted open source PostgreSQL technology support and training. Basically, if you want to think of who we are, we're the Red Hat of PostgreSQL, right? That's our business model. That's what we aim to be. We have some of the leading contributors to PostgreSQL code, like Paul, but also Stephen Frost, Tom Lane, Joe Conway, approximately 1/3 of the contributors to Postgres, right? So we can both influence, we can do stuff in the code, but we can also, work deeply connected to the community. Everything we do is 100% open source and runs on Postgres, right? So no open core. Everything we do is pure open source. Our claim, just like Red Hat's, is engineering quality support, right? So that's one of our big ones. You get calls with skilled PostgreSQL engineers 24/7, 365, usually 20 minutes or less. And so one of the examples would be like if you had something going on with PostGIS and you were one of our customers, you probably wouldn't get Paul on the immediate call, but you get Paul probably on the second call after they'd figured out what the problem was. And then one of the other big things for us is commitment to security conscious enterprises. We have a lot of security clearance, and we worked on the STIG for Postgres. So we've done a lot with security, and we're cloud and platform agnostic. And we've been working with containers since day one with OpenShift. Actually, with OpenShift, we were building containers back when OpenShift was not running on Kube, but we quickly made the conversion to Kube and OpenShift, and then we have been doing an operator for quite some time, and you'll see it in action today. So here's just some stuff about how we've worked with Red Hat before. Ansible Tower now uses Postgres behind it, and Satellite also uses Postgres behind it, and we are one of the preferred partners if you want HA Postgres behind Satellite or Ansible Tower, right? And anywhere else you want to do, if you're running like Jira, or if you're running, what was the JFrogs? I don't remember JFrogs, but behind JFrogs, we can run behind JFrogs as well for HA. So here's what Ashesh, the GM Cloud BU, I think he's a senior vice president now for Red Hat and cloud in general. And here's what, I'll let you read it. I'm not going to read it out loud. Well, actually, I should in case there's someone that's vision impaired. We are very excited to see the great results of the work that Crunchy Data has put into containerizing and operationalizing Postgres in the OpenShift environment. Having effectively built a database as a service infrastructure, Crunchy Data has made it easier for application teams to use the power of PostgreSQL in their modern architectures. So that's from Ashesh. And then Chris Morgan, the lead tech marketer, one of my good friends on Red Hat Cloud. This is about our operator certification. And this is just to attest how long we've been doing the operator on Kube with Red Hat, right? So and we're actually in the catalog as well. As they have for several years, Crunchy Data has been a first mover in their collaboration with Red Hat. Being one of the first partners to embrace the operator frameworks demonstrates this, and we're excited for Red Hat OpenShift customers to be able to take advantage of this technology to help address their PostgreSQL needs in a scalable and repeatable fashion. And quickly, if you know about operators, which you should, since you're on the Commons call, we are actually at phase 5. So we're on the autopilot mode for our operator. And you'll see a demo of our operator. Adam's going to demo that in a little bit after Paul does his thing. So I tried to go through that relatively quickly because I know most people don't want a lot of marketing. So if you have questions, you can put it in the chat or reach out to, we have a slide at the end of how you can reach out to us. I am now going to turn it over to Paul.
Great. And I'm going to talk a little bit about the motivation behind Crunchy Spatial. So it's not uncommon in our connected world for you to want to put a map on a computer, but if you're coming to the problem for the first time, it's all too common to be sucked into the tar pit of being told that you need a great deal of different, new, extra complex software to do it. You need a geographic information system, my friend. You need a GIS. But actually, if you're building an app, probably you're building an app using a database underneath it. You've got Postgres in your app, which means you can easily have PostGIS in your app, which means you already have the GIS. Effectively, PostGIS gives you all the functionality of a GIS without having to bring the GIS into your infrastructure. You already have the functionality in your database, in your spatial database, Postgres with PostGIS. That means you can answer GIS-y questions, things like what parcels are within a kilometer of the file. That's a GIS-y question. It's a question you can visualize in a mappy sense. What things are within 1,000 meters of the fire? And you can express that, the answer to that question in SQL if you have a spatial database. And not very much SQL either. This is one SQL statement. It's 5 lines. It's a few enough words I could count them on 2 hands. How far did the bus travel last week? That's also a GIS-y question. You can think about it in a map. You can express it in spatial SQL. Find me the nearest truck to the transformer. That's actually a somewhat more complex question because I got 2 things going on there. I got transformers and I got trucks. Can I find the closest thing using just spatial SQL? Yes, I can. Not even very much. This is an index nearest neighbor query. What trucks are in the service depots? Trucks and service depots, 2 layers. This is an example of a spatial join. Again, you can express it in SQL and hardly any SQL at that. So you can get all the functionality of a GIS without the GIS when you've got PostGIS in your PostgreSQL database. So you're building a web app. You haven't sold. You think, how do I get this wonderful thing? I'd like to use this this GIS without a GIS that you speak of, Paul. How can I get this wonderful thing? And it's in the Postgres database, so you just have to connect to port 5432. And you're building a web app. You're building an app that runs inside your browser. The things you connect to from that web app are web things. You're connecting on port 80 or port 443 for SSL. So you've got this disconnect here. You've got a web browser sitting out there that wants to connect things on HTTPS. You got this database back here, which likes to talk to its clients via the Postgres query protocol on port 5432. How do you join these 2 things together? Historically, again, you might say, I need a GIS, or rather, I need a GIS middleware. And we looked at that and we said, you can do that. But the GIS middlewares that existed and still exist are quite heavy. They do a lot of things. And we already have all the things back in the database. So we need the smallest thing that can do what we need in order to bind a web app to the spatial smarts of PostGIS. That is, we want to be able to send a query over HTTP, and we want to get back one of 2 things, either map tiles so we can make a visual display, or GeoJSON so we can get a little bit more interrogation into the features and make something a little more interactive with features. Those are the 2 things we want back to be able to put into a map panel to be able to build into a spatial application. So we asked ourselves, looking at sort of the big weighty spatial middleware, what's the smallest piece of software that can do the thing we want? And the advantage of small is that it's easy to deploy. It's easy to take a small thing and put in a container because it doesn't have a lot of moving parts. It's easy to reason about a small thing. It only does one thing, so you can figure out how it works. And because we're doing all this in open source, another real big advantage of a small thing is it's easy to contribute to. Contributors can come in, they can look at the relatively small code base and say, I need to do this one extra thing. Here's a contribution. Whereas it's a very large, substantial project. It can be a very big problem just to figure out how it works before we can contribute. So what's the smallest piece of software that can solve this problem? And so we started building these small pieces of software. We built 2 to start with. We're just calling it PostGIS for the web, PostGIS for the win. PG TileServe is a very small piece of software that provides HTTP endpoints so the web browser can talk to it. and exposes the tables and functions in the PostGIS database, returning vector tiles. And vector tiles, which you'll see in the demos that Adam's going to provide, give you a rich, attractive, and also potentially interactive way of working with spatial data in a web map. PG feature serve, same idea, except that it returns GeoJSON collections as the response. Gives you endpoints for tables and functions, and returns collections. So PostGIS for the web is GIS without the GIS. It lets you take your web app, bind it to all the smarts, the GIS without the GIS in PostGIS, and build rich web applications without having to commit yourself to huge chunks of GIS. Returns GeoJSON collections. And that's the motivation for Crunchy Spatial tables and functions, and returns collections. Kick it back over to whoever's next. So PostGIS for the web is GIS without the GIS. It lets you take your web app, bind it to all the smarts, the GIS without the GIS in PostGIS, and build rich web applications without having to commit yourself to huge chunks of GIS. Returns GeoJSON collections. And that's the motivation for Crunchy Spatial tables and functions, and returns collections. Kick it back over to whoever's next. So PostGIS for the web is GIS without the GIS. It lets you take your web app, bind it to all the smarts, the GIS without the GIS.
Paul just did an awesome job giving you a brief review of kind of the motivation behind Crunchy Spatial and that's the motivation PG Tile Server and PG Feature Server. So what I'm going to walk through now is how we actually put that into real-world practice using OpenShift. So the demo architecture that I'm going to show you here starts obviously with PostGIS as our data layer. We're going to do an awesome job feature serve and PG Tile Serve in our microservice layer. We do have a raster tile map server to serve up static base maps, so you have something nice to look at underneath your vector tiles. And all of that is going to be served up into our custom written demo application, which is a React application. So I'm going to walk through that in real time here in just a minute, and then once I walk through how to build that up in real time in OpenShift, Steve and I are going to show how you can do editing in real time in a cloud-based database, and it's actually going to be leveraging another feature found in our Postgres operator for Kubernetes that allows for multi-cluster replication between two Kubernetes clusters. So when we get to that part, what you're going to see is essentially the same application, but now we have two separate clusters of OpenShift stood up, and we have two versions of the application, one running in each cluster, and but only one of the applications is the primary application, but data is being automatically replicated and fed over to our standby cluster. So if for whatever reason something happens to your entire Kubernetes cluster, you have the ability to fail over and restore your application in very short order in your standby Kubernetes cluster. And also some of the inherent features built into our operator that come out of the box are high availability for your Postgres database, and we're gonna show how an auto failover works over just in our primary cluster as well. So that's what I'm going to show you here in just a second. Let me go ahead and exit out of this view. All right, so what everybody should be seeing here is I have my two terminal windows where I'm going to be doing the majority of my work, and then I have my OpenShift cluster UI here on the left side of the screen. And as I'm working in my terminal, you'll start seeing pause and jump in. Yeah, Steve?
We don't see it. We're still looking at the slide.
Yep. Yeah,
all right,
correct.
Well, let me reshare.
Nice. Nice, Adam.
Well done.
All right. We have the technology.
Surprisingly so.
All right.
Yes.
So like I was saying, we've got my two terminal windows where I'm going to be doing all of the main work, but you're going to start seeing all of our pods drop into my OpenShift UI over here as things start getting built. So what are we going to end up building? So this is a view of the end user application that we're going to end up building. It's a demo application that we built just to show off the power of Crunchy Spatial and Postgres and Kubernetes. And what you're going to see is it's a purely fictitious application that we thought might be representative of how a fire administrator in Santa Cruz County would be managing parcel information to denote whether or not a parcel is considered a fire hazard or not a fire hazard. So what you're going to see is all these green and red lines are tax parcel information that we actually downloaded from the Santa Cruz County website, GIS website, and we loaded it all into a database, and then we fed it out through PG TileServe, and we interact with it through PG FeatureServe. And what allows you to do is select on a particular parcel, and then it allows you, in this view, it's meant to represent a fire administrator being able to change whether or not a parcel is considered a fire hazard, save that off, and then the update is actually done directly in the database. And then the next view is same map, same view, but only in this case, a fire administrator may want to let a number of residents in a particular area know that a parcel is being updated to be considered a fire hazard. So it allows you to do a geospatial query, again, directly against the data in the database, and none of this is being done in the UI, and return all the parcels that interact or intersect with that query radius. So obviously we've already got this application stood up and running. Just wanted to let you get a sense of what we should see working when the demo is completely done here. So with that, let me go ahead and drop back into this view, and we'll go ahead and get started. So the first thing that I need to do is I'm going to make sure I'm actually in the demo project space. So I'm building these things in the right space so you can see it working. So I'm going to go ahead and switch to my demo project, and I'm going to start by actually building our UI first, since the UI is actually the part that takes the longest to build in this, because we are actually building from source using the source to image feature in OpenShift. So I'm going to go ahead and drop that command in here. And you can see I'm just grabbing it from my own Git repo, a particular branch, and telling it to use the source strategy. And I'm going to go ahead and kick that off. And if we go over to our builds, we'll see that is actually, well, wait for it. Might take a minute. There we go. So now it's actually going. We'll see. We should see a build config pop in here. Oh, there we go. There's my build config that popped in, and we should see the build start going here in a second. So while that build is going, this React application needs a couple more things to make sure it's running appropriately. So I'm going to go ahead and set the environment variables in the deployment config for this particular application. That's necessary. So this isn't particularly germane to spatial or anything like that. This is in particular more of a React function. So I'm updating the deployment config for this, and you can see that just got updated. So if I go here, I can take a look at the environment variables. Yeah.
Your screen is well behind your voice. What we're seeing on the screen, just to let you know, is that fire notification. It's still showing that screen. We have not yet switched to showing all the work that you've done on the other terminal.
And Adam, so it might be that your Wi-Fi is a little lag time. So maybe turn off your video if you don't mind, and that might be the load on your computer.
Yep.
So I'm going to do that.
Okay.
So if you don't see his face now, that's my doing.
We look Adam and I look very similar, so you can just look at me and pretend I'm Adam. Okay, Adam, well, hold on. You're just resizing your stuff. You can start over with from the part where you entered there's Adam entering the command to you. Yep. He's logging in to the demo project, and he's building this OC new app, which people should know. He's building this. This is a Node, a JavaScript application that we built using React on the front end. And then you can see that, like Adam was saying before, there's the build config coming up, and that build's going to be kicked off. So that's going to be doing the whole source to image process inside of the OpenShift build. And so that build's running. Adam, where did you leave off? Oh, no, now
So
he's setting
just
he's setting some environment variables, right, for that app. You can see that there on the right side. He's just doing the OC SETI NV for the deployment config for spatial web demo. And that's updated. And then you
that
can
should
see
be
that
where
on the left side.
I stopped. I left
Okay.
off.
Now you're
So
exposing the
nice.
service.
Yep. So we'll go ahead and now we're caught up to real time. So
Okay.
I'll start walking through here. Hopefully me turning off my video is going to help keep things a little bit closer to real time. But Steve, please let me know if it starts lagging in any way, shape, or form.
Sure thing.
So, and then the next thing I want to do in this project space, let me go back over to my pods view here, is, and you can see every time I made an update, it created a new deployment for that. And so the next thing I wanted to be able to do is add in that static map tile server that I mentioned we needed to have. So again, this is just a custom map tile server that we built for this demo. You can replace it with your own map tile server. There's a bunch of different map tile servers out there. Again, not particularly germane to anything related to PostGIS or the spatial product, but something necessary for the overall application. All right, so now we've got the map tile server and we've got our UI, but we don't have any data actually up. We actually don't have a database. So if I went to the just the view real quick here, you can see we've got the spatial web demo, which is our front end, but but it actually won't have anything in it. So I won't even bring it up because you'll see just a blank app there with no map on there. So now we actually want to get into the meat of the demo and start deploying our backend PostGIS database. So I'm going to switch to the project where we have our operator deployed, and that's called PGO. So now I'm in the PGO space, and I'm going to log into our PGO client, which you can have the PGO client. It's just a CLI tool. You can have that loaded on your local machine. We also do offer the ability to deploy it actually into the cluster where you have PGO deployed. So that way you don't have to be dependent on anything locally on your machine. So now I'm remoted into the client itself, and here's where I can actually issue the commands to deploy the cluster that we need. So first off, let me find where I'm at here. There we go. So what I want to do here is using the PGO operator, which is Crunchy's operator for Kubernetes to deploy Postgres clusters. I'm going to issue a command to create a cluster. I'm going to tell it to create it in the demo namespace where I'm building this application. I'm going to give my Postgres cluster a name called Fire App. I'm going to tell it which particular image of the Crunchy containers that I want it to use, and that is the Crunchy Postgres GIS, so that means that it comes with PostGIS pre-installed and our HA container. I'm going to create a database as part of this command. I'm going to call that database Fire Data, and I'm going to tell Kubernetes that I want one replica created automatically on this, and then I can define my password for Postgres as part of this. If I left this off, then Kubernetes would go ahead and automatically create a random secret and in the cluster, and I wouldn't have to specify this. I'd just specify the password for the sake of this demo just to make it a little bit cleaner. So I'll go ahead and kick that off, and you can see it went ahead and kicked off a workflow. And if I do a PGS show, we can see that it's in the process of creating the initial cluster, and then it has the replica running or starting to run as well. And you can see over here the first container just created. We've already got our backrest repo created here, and now it's spinning up our primary cluster node. And once this is done, we'll see another cluster pop in here as well. So I'm going to give that a second to run. And then the other thing I need to do is, again, based on the way we have this data structured, I need to create one user Again, this is all being done through our Postgres operator, and I need to create a user called Groot, and I'm just going to have Kubernetes manage the password for us here. But again, telling it what namespace to look in and what cluster name to create the user in. So if I do that, you can see created our user there, and so now we have a Postgres cluster or a Postgres cluster. We have a user created in our space, and so now we need some data in that space. Now, as Steve said, we're not going to go through all the painstaking steps of actually downloading shapefiles and loading in. We do have a database backup pre-staged, so I'm going to switch down here real quick and switch to the demo project, just so I can stay logged into PGO up here. And then you can see now we've got a primary cluster or a primary database running, and then we have a backup still in the process of being spun up here. So I'm going to go ahead and remote into this one. So now I'm actually inside the pod in OpenShift. So I'm in this pod, and I want to load data into that Fire data database that we created there. So I'm just going to go ahead and issue a psql command. So like I said, we've got this this Postgres backup pre-staged in Amazon S3. That's going to pull it down, and it's going to load it directly into the database in real time. So you can see just that quickly pulling it in and restoring the database backup. And we're done there. So now we have a front end, we have a map server, we have the database created with the data in it, and the Postgres extension created in there by default because we use the Postgres container, but we still have not connected the back end to the front end. So now I'm going to deploy PG tile serve and PG feature serve and connect that to the database. And when PG tile serve and PG feature serve are created, they automatically expose the data inside the database and make it available, which those REST APIs are already part of the web front end. So when we actually connect that, and now I'll actually jump over here so you can see where we're at. So real quick, like I said, so here's our demo front end that we actually just built. So it looks very similar to what I showed you earlier, right? There's no changes. The only difference is we don't see those green and red lines here, right? We've got the base map, and we've got the overall UI framework, but we don't actually have the data. So just to show that I'm not don't have any tricks hidden up my sleeve here. So.
And for those who are wondering, another name for that base map is the raster tiles. So when Adam was talking about that before in the architecture, that's basically just a pod that's just serving up raster images that mosaic together to form that base map layer. Yeah, and maybe an easier way to show it, right, is so here is the demo front end that I just had OpenShift build for me, right? Like Steve was saying, here's the raster base map, and here is the one that we're going to be doing the real-time editing in a little bit. So you can see you got the green lines and the red lines. Those are the actual vector tiles being served back up directly from the database, which we're going to actually implement those services now. And here's our demo front end. You can see those lines aren't there. So hopefully that makes it a little bit clearer. All right, so jumping back here, go back to my view here. All right, so I exited out of the database pod in this window, and now I'm actually going to deploy PG tile serve and PG feature serve. So again, using the new app flow, we pull down tile serve, and again, just that quickly, it pulls down the container image. And to connect tile serve to the database, we need to set a couple of environment variables. So the first one I want to be able to set, actually here, hold on a second, make sure, pull this back up a little bit, make it a little bit easier because it's hard for me to see at the bottom as well. So the first environment variables I'm going to set is I'm going to set the username and password that PG tile serve is going to use, and I'm going to grab those directly from the Kubernetes secret provided by OpenShift.
and I just do that through this OC set environment command. You can see I'm grabbing the Postgres secrets, and I'm appending the PG prefix to it, so there'll be PG username and PG password in there, and I'm adding it to that deployment config. And then once those are actually set, the other environment variable that I need to create is the actual the database URL environment variable. And so this is what pgtileserve actually uses to connect to the Postgres database. And you can see I'm actually defining what that environment variable is there. But again, using PG username, PG password, grabbing the Fire replica, the Fire app replica service host. And so that's actually provided from Kubernetes. And notice I'm using the replica. So when I created the Postgres cluster, it created a primary and it created a replica database. I'm actually connecting pgtileserve to the replica database because pgtileserve is a read-only transaction. It's not actually doing any updates to the database, so we can use the replica service host on that because the replica database is a read-only database. So we want to offload any sort of workload from the primary database and put it on the read replica. So we'll go ahead and create that. So updated the deployment config, and you can see because I didn't have the deployment configs completely correct, you can see pgtileserve actually errored out because it couldn't actually connect to the database. But now that I've actually got it connected to the database, it's completed, it's actually running, and it's up. And the last thing I'll need to do is just expose that service so we have an available route to actually access it from our application. So go ahead and expose that service. So if I jump back over here to my routes, now we have pgtileserve. And just to give you an idea of what that looks like, here's a basic UI out of the box from that comes with pgtileserve. And we can go ahead and click on this preview. And again, this is just it's a memory limited UI, so you're going to see these vector tiles come in a very spotty way because there's just a lot of them. But you can see all of the vector tiles returning back here, and it returns all the attribute information contained in the database. We are not going to be using all that attribute information in our end UI, but just let you know that it is made available to you through pgtileserve. All right, so close out of that. So we've got pgtileserve there, and if I actually
wait, one more thing, Adam. So yeah, this is what Paul was talking about before with why a vector tile is better than a base map tile. So if you looked at, if we went to the base map tile and clicked on the map, you wouldn't be able to get all this information returned for each individual parcel, right? If this was just raster tiles. But because it's vector tiles, we can actually tag information to all the vectors, allowing us to not have to necessarily go back and forth between the web server and the database server just to get display of information. And you can also style on the fly, right? The raster tile server, the one that we had before, those are raster images, I think JPEGs or PNG, something like that. So once you make that styling, you're done. Here, you can dynamically style the vector tiles and the parcels in them based on any of those attributes that you see there associated with them. So it gives you a lot more flexibility in terms of display and cartography.
Yeah, thanks, Steve. And so now I brought up the demo application that we're building in real time, and by comparison, now you can see it looks very similar to the application I brought up initially. But now I can click on this, but the UI doesn't let me do anything, and that's because all these interactions through the.
You're behind again, Adam. Hold on, you're behind again.
Oh, sorry.
I'm assuming right now you're actually looking at the demo app, right?
Yes.
Yeah. We're not. Okay. We're still seeing the vector tiles.
We're finding out that the internet is not evenly distributed today.
No.
In rural Wisconsin, wherever you are, the digital divide exists.
It is very, very real. Believe me. Yes.
I can imagine, and there's much more work to do.
Yeah. So let me know when it's caught back up to kind of the base map there, Steve.
Okay. Still waiting.
That's okay. I was joking with Steve a minute ago is that a long time ago, I was doing demos on OpenShift, and I was deploying WordPress with OpenStreetMaps and things like this. And there we go. We've caught up now, and we've come a very, very long way. So now we're on your screen.
Okay. All right. So what I was starting to show is so even in the demo UI now we've got the parcel layers here, right? We can see the green lines, the red lines. We can even click on them to select them, but when I actually try and use the interface here, it doesn't do anything, right? You can see an error has occurred, and that's because we haven't deployed PG Feature Serve yet. PG Feature Serve is actually what drives the interaction or allows the interaction with the database. And that's because all of that interaction is being done through functions that were created in the database, and we'll walk through that as I build out PG Feature Serve. So I'll go ahead and reduce this back down. All right, let me clear this.
Talk slower, Adam. We got to wait for it to catch up. Okay, there, good. We're back.
I'll take longer pauses. There we go.
Nice, nice. Very contemplative. Good.
Yes.
I like it.
All right, so first I'm going to go ahead and same workflow that we did for, whoops, I don't want to expose the service yet because it hasn't been created. So same workflow for that we did for PG Tile Serve, I'm going to do for PG Feature Serve, or maybe I'll just stammer and stutter a lot, and that'll take a lot more time. So same thing, grabbing our PG Feature Serve container, pulling that down. We're going to set the same environment variables that we did for PG Tile Serve. And then add the database connection URL as well. And actually, before I post that in there, I'm going to go ahead and clear this out just to make sure it's a little bit easier to see here. So the main difference, though, is because PG Feature Serve is actually going to be updating data in the database, we don't want to connect it to the replica service host. We're connecting it to the primary. So you can see that right there. And that's because the primary is what allows us to actually make changes to the data in the database. So PG Feature Serve is connected to our primary database. PG Tile Serve is connected to our replica service host. And that's actually going to be something important to keep in mind in a little bit as we show the auto failover workflow between the two here. So went ahead and updated the deployment config there, and then last but not least, expose the service out. And so now jumping back over to this UI, I can go to our routes, and you can see we've got PG Feature Serve as an available route now. Bring up the PG Feature Serve, just kind of stock engineering UI. And if I go to collections, you're going to see the same layers that we had available through PG Tile Serve. These are being returned back as OGC APIs, though, so they're a lot more rich, a lot more feature dense, if you will. And we also have the ability to view functions. Now, if I click on here, we don't actually have any functions available to us yet. We are going to create those in just a minute. And as I said before, the interaction for our application is actually being done through functions that reside in the database that are accessible through PG Feature Serve. And so even though we have PG Feature Serve deployed now, it is actually available through an API. If I go back to our demo application here and refresh, I still don't have the needed interaction. I can still click on these, I can highlight them, but when I try and do anything, it doesn't actually do the update, again, because we're missing those couple of key functions. So the functions that we're going to add are two pretty simple ones. We're going to add a parcel within distance. That's going to allow us to do our distance query, and then our parcel set fire hazard function, and that's what's going to allow us to set the attribute information in the database from the fire hazard attribute from either yes to no or no to yes. And so you can see here's the code that is required to create those functions. And so now I actually need to create those in a database. Well, we've got this saved off as a data definition language or library in the SQL format, and I've got that pre-staged. So in the same way that I was able to restore our database backup, I'm going to do the same thing down here. Go ahead and just RSH back into that database. The other thing I should add in here as, so right now, PG Feature Serve has to look for the PostGIS FTW schema. So you can see over here, that's the first thing that happens in this DDL is we actually create that schema, then we create the functions within that schema, and once those are both created, we'll be able to see them in the PG feature serve UI. And I should probably stop trying to multitask because they keep messing things up here. All right, so now I just remoted back into the primary database pod. And now I'm just going to go ahead and grab the command here to restore that DDL. So again, in the same way that I was able to do the database restore, just go ahead and grab the pre-staged. Oh, that didn't work. Why didn't that work? Try that again.
Didn't work because it's live.
Of course, that is exactly why it didn't work. Second here.
You want to try curling it directly from GitHub?
No, hold on. I gotta be in a temp directory. There we go.
Okay.
That time. There we go. Helps if I have the have it in the right place to actually be able to write the file. So there we go. We can see that pulled down that DDL and then just loaded it directly in. It's got a whole bunch of awesome coordinates in there as part of the test. And so now going back over to our interface here, let me go full screen. Go back to my PG feature serve UI. And if I view the functions, now we can see we've got the two functions that we need here, the parcel set fire hazard, parcel within distance, and jumping back over to our demo UI. Now we'll see that we've got a fully functioning interface here. We've got all of the attribute information back here that wasn't present before, and I can go ahead and hit yes, and you can see it changed to red because the attribute information was actually updated directly in the database. And I can go over to the active fire notification and select that. And now I can do my distance query. We'll do a different distance this time. And you can see I'm getting all that information returned back. So now we have a fully functioning web application, and it was all built out in real time. That took me maybe about 20-25 minutes, including time to actually pause and let the system join up here. And so I'm going to go ahead and make a couple more changes here, and we're going to do just another quick live demonstration on the failover capability. So you can see I'm making a few changes here, and the reason why I want to do this is to show you that it's actually being stored off in real time in the backup, and it's going to be restored from failure. So we can, so I changed this parcel, and this parcel to red from green. And if I go back into, let me shrink back down here real quick. So remember this view, I'm still in my primary Postgres pod. And so I can see PG data is where all of the primary data is actually restored. And let me just do one more quick PGO show up here so you can see. So here are my databases running in my cluster. So we've got my primary here. So remember W7CJ2 is the primary and the replica is GNTSB. So I'm going to go ahead and intentionally crash my database, which is always something fun to do in a live demo, right? Because that's what you hope doesn't happen, but we're going to go ahead and do it just to show how auto failover works. So I'm going to go ahead and remove the PG data file and
lowercase r.
Oh, thank you. And it said permission denied, but actually if I go back up here and show, you can see now our primary cluster is in an unknown state because I corrupted the data file. And now it automatically, in just that amount of time, it switched the GNTSB to primary. So it actually tore down and it's in the process of restoring the former primary back to a replica. And you can see just that quickly, now that's back up on replica. Now, you can see, well, obviously nothing happened here. If I go back here, all the data is still the same as we had it before. But remember, when I connected PG TileServe, it was connected to the replica service, and PG Feature Serve was connected to the primary service. And so I can still go in here, even though the cluster has failed over and the nodes are not or the pods are not the same anymore. I can still go in here and make updates to the database. Let me select that one. Let me change that back to no. And you can see the interface is still fully functional, fully working, and just that quickly, the operator went ahead and failed over from the replica to the primary, and there was no impact to our user application. So when you're talking about a mission critical application, a business critical application, data assuredness, you want to make sure your data is always up, always available. Having a highly available Postgres database driving your backend application is a critical piece of that, and really helps make sure your application is always up and your data is always available to your end users. So Steve, that wraps up the real-time build of the single node instance. Do we want to switch over and show how you can remote in using QGIS and doing data updates? And then we can also show how it's being replicated between the two clusters.
Sure. Before I do that, though, can I put you on the spot?
Sure.
Do you remember the command to scale up the replicas?
Oh, yeah.
So the reason I wanted to ask Adam this is, so we showed that the failover happens, but also you can set auto tuning for you can set auto tuning to let it scale up on its own. We don't actually enable that for the most part because databases are you don't want to be spinning up replicas and creating all that bandwidth in general, but you can manually go in, and if you do this again, you'll see that we can actually just create another database replica on the fly. So if we were serving up a lot of tiles and it was really there, so it just created 2 more replicas, right?
Yep.
So we just increased by 2 more. So now we're running 3 replicas. And this is also the part that shows how PG TileServe and PG Feature Serve running inside of OpenShift are cloud native, right? Because there's no state stored in PG TileServe or PG Feature Serve, right? There's no state stored in there. All the state is in the database. So if you really actually need it, we're now reading off of more replicas, but we can also take TileServe and we can just go ahead and just scale it up. And it doesn't matter, right? Like it's always talking to the service. So it'll know how to route to the replicas that are behind that service. And now we have 3, and so they're load balancing to the replicas in addition to having 3 new services coming up, right? This isn't something where there's state stored somewhere other than, like there's some other map servers out there where they store state actually in the application itself, and those become very hard to scale up, and they're actually quite a hog in terms of resource usage. If you look at Feature Serve right now, so if you click on, do we have metrics for them?
I can probably, yeah, let me hop over.
I think if you just click on the, oh yeah, you can click on that too. You can, well, that's the larger view, but if we look at it later, we're going to actually be able to see the metrics for the specific pieces, and you can see that they're basically consuming almost no resources to do their work because they've built in a lightweight cloud native format rather than a one app server to rule them all kind of format. So I just wanted to make that point clear while Adam was doing his demo. So I'm going to take control now.
Yep.
And so let me make sure people can see, you can see my map?
Absolutely. Yep, we can.
Okay. So this is the exact same map coming off of Adam's space from before, right? And you can see we've got the, let's see if, I don't know if we're serving in the exact same. Let's check. Let's go here to refresh the state on the map. We come back here. This is the one of the demo, because this is actually in the failover cluster that you know, that replicate we had where the data was being replicated between actually two distinct OpenShift clusters. I'm attached to that data set right now, right? And that cluster. This is the primary in that cluster. That's why you don't see Adams changes, because pre-configuring all that cluster change is not something we can do easily on the fly. I mean, we probably could have, but it's in the essence of time, we preset that up beforehand. So what I'm going to show now, though, is it's quite often in GIS frameworks that the users are desktop application users, not web users, right? Like, so that web administrator view that we showed before, that might be good for someone who's not into the GIS stuff. But for the GIS people, they actually usually use a desktop application. So I have a desktop application up. I did a port forward. So here you can see me, oh, it's not on the screen. Here you can see me port forward to the primary, right? The primary doesn't have any letters. There's like the replica has some letters, another set of random letters in it. So we're actually talking to the primary. And I've port forward 5432 to 5432 on my local machine, which is the port for Postgres, right? So we're connected to that. Move that back out of the way. And then I'll bring up the desktop app. So inside of here, I had already made a Fire spatial connector, right? And that is actually connecting to the database in the primary, right? And we can see everything in there. I've already dropped assessor parcels on here. We're going to actually update this parcel here. This one was already Fire, so if I click on it and we look all the way, I don't know if this is actually viewable on your screen, but if we look all the way, let me see where I can find it. So Fire Hazard. Oh, we clicked 2. We were too far out. I need to click that one. Yeah. Let me scroll down again. And went too far. Where is Fire Hazard? Anybody see it?
Then you might have just passed
There it is. There it is.
Yeah.
There it is. So you can see it's set to yes. And if I go back to my map view quickly, we're looking at this parcel right here. So we're going to do the use case where there's a GIS analyst, a desktop analyst, back at the main spatial processing center for the fire department or for the county. And they said, oh, you know what? We've gone out and inspected this one, and this parcel is actually now high fire potential. So what I can do here is I'm actually going to select this parcel, right? And we can look down at the fire hazard again. And it's, where'd it go? There's a lot of attributes, but you can see this one says only yes portion, so not the whole thing. We want to change that. So what we're going to do is we've selected this. We can start editing on this. So toggle editing. Now this allows us to make changes through here. And then we bring up this form for changing things, and we scroll down to there. Oh, no, that's timber. That one always catches me. Here, fire hazard. So we're going to go and edit it. All right, so we're editing on the primary. There we go. It's all done. You don't see anything in the GIS view because you wouldn't. Did I toggle editing yet? Nope. I got to turn off the editing. So that saves. So this is basic. Toggle editing basically opens up a transaction. And when I save, that actually commits the transaction to the database. And now, if I go back to my view and I refresh the page, I mean, if we were really fancy cool, we would have some sort of WebSockets, but it doesn't happen often enough to do WebSockets. But now you can see that it's gone out to the replicas, right? Because the replica is controlling the tile serve, and you can see that tile serve is now saying this is a fire hazard map, right? This is fire hazard. So that was right to the primary, replicate the data to the replicas, and then serve it up and change the map. And so you can do this you can do a dual functionality or dual user type role, given that we can have stateless servers and that we have access to this database with all its replication set up for us out of the box. And so you can have desktop people changing data and analyzing data, and they're the only ones that have permissions instead of doing it maybe through here, or you can have web users do it and it's all synced up together. The other benefit that would have happened is in here, if I wanted to run those functions in the FTW, PostGIS FTW schema, I could have actually run those functions as a call inside the database here. So like Paul said in the beginning, we believe, like, not surprisingly, that the database is the center of all the knowledge. And this way, any client that connects can actually use the same functions, change the same data, everything's replicated and synced up, and the database is taken care of by the operator. So with that, I'm done with the changes. And now comes the part like the 1812 overture where the cannons go off at the end, where Adam, hopefully, fingers crossed, Adam was going to demonstrate failover between clusters. So let me, Adam, you can take back the, go ahead, take back the presentation if you want. I'll stop sharing, or you got it.
So, yeah, the 1812 overture is going to be a little less dramatic. I'm not going to demonstrate the full failover, but what I do want to demonstrate is just the replication between the failovers, because as I was showing before, in a single cluster you can do automatic failover on a single pod. Between two clusters, it is a little bit of a manual failover process. When your primary cluster goes down, you switch over to your standby cluster. You have to bring that down, and then you have to promote it back to a primary. It can happen very quickly, but it's not automatic. And you also want to be very deliberate about that, because maybe your primary cluster, you want to just go ahead and spend the time to bring your primary cluster back up, your primary Kubernetes cluster, and not do the full failover. So you want to be a little bit more deliberate between failover between clusters. But what I do want to show is, so here we're back in OpenShift, obviously, and I'm going to go ahead and jump to. So instead of the demo project, I'm going to jump down to the project that Steve was just showing. And so here's where we have all of the, we have the multi-cluster version of it stood up. You can see we've got the same version of the demo here. So I'm going to go ahead and clear all these out, make sure I'm using the right one. And so we have this version of the application running in the primary cluster. Here's the version running in the standby. You can see there's a little number 2 right here that tells me I'm on a different one, but they should look identical. And what I'm going to do here is, you can see here the changes that Steve just made. I'm going to go ahead and change this back. I'm going to say, Steve, you messed up. No, that's actually not a fire hazard. And turns out this one wasn't a fire hazard either. And so I'm going to go ahead and change that to no. So you can see these two have been changed to no. I'm going to hop over here back to our standby cluster. You can see they're still showing up as red. That's because to replicate over there, it does have to go through an S3 bucket, and it takes about 10 seconds or so for that replication to actually happen in full. So I'm going to go ahead and just give it a couple more clicks. And you can see already just in that a little bit of amount of time, these two have changed. But again, because this is on the standby cluster, I can't actually make any changes to this one, because this entire database, including the primary one, is marked as a standby. So we're not going to run into any sort of transactional conflicts by somebody accidentally going to this one and trying to make an update to this one. It's not going to let me, because the entire database, primary and replicas, are only in read-only, and they're pulling from the primary cluster in the primary Kubernetes instance. But I still have the ability to do my radius search here, just because that's just a basic query there. So I can go ahead and do that. So hopefully that highlights the ability to not only do a highly available Postgres instance in a single cluster, a single Kubernetes cluster, but also being able to do replication between Kubernetes clusters. And again, there's all sorts of interesting different architectural things that you could do with that. Now, again, when you're replicating at the database level and you're making sure that all your data is consistent and available throughout your architecture, and if any one part of your overall enterprise architecture goes down, you have your data available in different instances, and you can quickly restore and bring that back up and replace your active application. And so with that, I'm going to go ahead and bring the slides back up here, hopefully. And so as Steve mentioned, If you want to learn more, you can always go to our website and learn more about Crunchy Postgres for Kubernetes and the documentation. We do have a learning portal, so if you go to crunchydata.com, go to our learning portal, or learn.crunchydata.com. Steve's got a great site there full of Kata Coda courses, not only for the Postgres operator, but a bunch of other Postgres courses. You can learn more about Postgres, obviously Crunchy Spatial, or you can email us at info@crunchydata.com. So with that, Steve, I'll hand it back over to you. Any closing comments?
No, I hope people got a sense of the way that we've moved into a cloud native architecture for spatial, right? If you look back to can I just show my slide just for a second? I'll show my slides. Here we go. So if we look back at this architecture diagram, I don't need to do the two different ones together. All of this is made possible by OpenShift, right? This high level of automation. If you notice, we had similar commands for every single thing we did, right? There was a common operating plane coming through OpenShift. So if you were to stand up this cluster yourself, you don't have to learn how to install Postgres, right? You don't have to learn how to install PG feature serve. You don't have to learn how to scale it up. You don't have to learn how to put the load balancer in front. You don't have to do any of that stuff, right? Or even the tile map server, which you could scale up. It's the same paradigm you would use for anything else, like Nginx or JBoss EAP. It's all the same paradigm for how you work with it. And the other nice part is we've got tons of automation going that is just taken care of by the platform itself. You saw the power of the operator, right? So the operator knew how to do failover on its own. We didn't have to read through and configure and do all that stuff that we would normally have to do to set up primary and read replicas, or the failover itself. That's years worth of work that all comes out of the operator framework and what we've done at Crunchy to build that Postgres operator. And then you saw we build PG feature serve and PG tile serve to be cloud native. They're small, there's no state, they scale up, they respect the way that Kubernetes is expected to work, right? You just set a couple environment variables for the password. You can actually even set them as in the deployment config directly. We built the configuration of it to work with Kubernetes and OpenShift, right? And so then you can build your UI layer, but all of it's taken care of and you're not learning some new paradigm. So we believe this is the way forward. I mean, Kubernetes, the cloud, all that stuff has really made it nice for us to do, as Paul said, Postgres for the win or for the web, both of them together, right? It makes it much easier for everybody and in a scalable way. So I just want to end, and we love talking about it. So any questions, shoot them our way.
Absolutely, and I'm sure we will. And this really, I think you really have shown us the path forward for cloud native and the future of GIS being a cloud native serious offering here. This is really amazing. I know, the internet may have failed us a few times here, but if people really clue into this replication between clusters and the different things that we were showing here, this is light years from where we came, jokingly with, plugins to different things, and the ability to drill down and scale this stuff now is just amazing. So I really appreciate you guys taking the time here. We will definitely have you back and do more live coding demos, because this stuff is just great. If you could throw up your last slide there with the resources as well, because I think that would be a great way to end. And I don't know if Paul still hanging around there.
I'll put up the last slide, but Paul's still here.
Yeah, if you want to just say if people want to get involved in the open source side of this, the PostGIS, where people should go to find you to participate in that community.
Yeah, if you want to get involved in PostGIS, the community site is postgis.net, and everything links from there.
All right, awesome.
Wait, hold on. I'll bring it up and I'll show. Hold on.
Perfect.
Let's go back to where is it? No, that's not what I wanted. I want this one. Hold on. Let me get rid of this. There.
Because that's probably Steve's homepage.
Right. Exactly. Which I just have QGIS of all the time. Where is? Oh, here's what I wanted. Here we go. Right. So here, PostGIS is PostGIS. Is it .net? So this is the PostGIS site, and then there's a whole part on it about development. Right. So here's how you get involved. They've got a nice list. They're very friendly people. Paul, I think it's mainly Paul and Regina that run it. Is that right? Pretty much, Paul.
Me and Regina are the most consistent people around, but there's a development community of about a dozen regular contributors.
Okay, but Paul and Regina are I don't know about the other, I don't know the other people. I'm sure they're very nice too, but Paul and Regina are some of the nicest people I know. And then if you want to get involved with our other projects, they are in github.com/crunchydata, right? And their repositories are, here's PG TileServe right on the front page, right? And as Paul said, it's really slim code. Like if you dig into this, I think the biggest thing in here is probably the documentation in Hugo, right? Or the examples. Most of it's happening he's doing it because the database is so powerful. You can basically, this is just a very small shim layer that just handles the HTTP to database transactions, and that's all it's doing. The database is doing all the work, so you don't have to do all this complicated calculations or writing inside the code. And then the other one is the exact same way. This is the one that Martin works on, which is FeatureServe. And it's the same. One thing we didn't get to show that I think I would like to show, since APIs are the future, if we go back to, now I have to find it, 3 deployments. I'm confused. I mean, I'm so used to the 3.whatx OpenShift interface that I get very confused with this new interface that you guys have going.
We're currently running a customize your UI contest. So if you're into that and you want to customize it backwards so it looks like the 3.x console,
yeah,
you can enter the console.
That's what I'll do. I'll just basically take the code base from the 3.1. I customized it. Look. So I wanted to go to the routes is really what I wanted to do. I was trying to find the routes. So here's the FeatureServe, right? I'll bring up FeatureServe again. And the thing I think that's really cool is features. The GIS world is usually a couple years behind catching up the rest of the programming world. But this time it's really great. Adam mentioned we're OGC compliant for FeatureServe. OGC is kind of like the W3, is it W3C, right? Is that the working group for the web, right? The OGC is that for spatial. And they're doing a whole, they're excited. They're doing a whole new configuration of it, they're rewriting their specs so that they're actually modern web. So the new FeatureServe spec is actually Open API compliant. And so as we bring this up, wait for it to wake up a little bit. It should be bringing up a Swagger interface to the FeatureServe. But the internet is not with us today. So it's waiting for unpackage.com. There must be a third-party library that it's waiting for that it can't get. So if I stop it, maybe, there we go. So now you get the Swagger spec for the FeatureServe. So you can interrogate it just like you would any other API, right? And it behaves exactly the same way. And again, it's stateless, right? So it's Restafarian or REST-like in what it does. So you can get the collection, right? How do I make that call? We put all the documentation in it. So I'm really excited about how we're pushing spatial forward. Focusing on the database, storing state in the database, but then making the other layers lightweight on top and cloud native. So now I'm done crowing about our site.
And now is Restafarian a thing? Or have you just...
I say that just because, there's a guy in the spatial community, Sean Gillis, who was very early in REST. And there was a bunch of us who were like tracking REST. And Sean was very Restafarian. And I think Restafarian are the people who follow Fielding's original dissertation and say, unless you're doing the original dissertation version of REST, you're not doing REST. Those are the Restafarians, and Sean was one of those people, and I was not. I was just like I'm just going to do what makes my life easier and programming easier, and if I put some function calls in there or something, so sue me. I don't care. I'm just going to make life better.
Hypertext is the engine of state, and I will fight you on that.
Apparently, Paul is also a Restafarian, too.
Oh, I can see there's a debate coming here.
Yeah.
Oh, goodness. Well, thanks again, everybody, for coming today. you know, as we said, the internet's not distributed equally, but I think we got the gist of everything here, and I'll put this up on YouTube shortly, probably end of day today sometime, and you will see it, and we can annotate it, put links into some of these things, and if you share with me your slide deck, I'll also link that into it too as well. So great work, amazing partners at Crunchy Data. Love what you're doing with PothGIS, Paul. So keep doing the good work there, and anything we can do to promote this, I'm thrilled with it, because I don't know anyone on the planet who doesn't like good maps, and yeah, really. And we use
Only
them.
people who have problems don't like good maps. That's all.
Yeah. Anyone who doesn't. I don't know if you can see it, but like I'm a huge map globe enthusiast. I even have my light bulb out there in the background. Is how hooked I am on mapping. So I so appreciate the work you guys do. So take care. We'll talk to you all soon. Someday we'll see you all again soon in person, hopefully. And so stay safe. Keep doing the good work. And we'll talk to you all soon. Take care, guys.
Okay.
Thanks, Dan.